All right. So what we're going to look at today is, hopefully you don't find this concept too difficult, trying to get your head around it. What we need to understand is we're going to look at the x and y intercepts. So when we're talking about x-intercepts, we're talking about where does this line cross the x-intercept. What we need to recognize from this is we need to recognize that any x-intercept, the y-coordinate here would always be 0. So for each of these coordinates, they would all have a 0 coordinate. Like that would be 3, 0, this would be 2, 0, that would be 1, 0. They've all got a y coordinate equals 0. So y is always going to equal 0. Y will always equal 0 on the x-intercept. This is a really important concept to know. Similarly, for the y-intercept, we know that x coordinate is always going to be 0. This is going to be 0, negative 2. This is going to be 0, 3. This is going to be 0, 4, and so on. So we know that x will equal 0 on the y-intercept. So you just got to understand the Cartesian plane to access this. I mean, anywhere on this y line, the x coordinate is going to be 0 because this is 0, right? Everything is going to be 0. Similarly, anywhere on this x-axis, y will always be 0 because that's your y coordinate. It's not going to be 1. It's not going to be 2. It has to be 0 to be on this line. So when we're talking about intercepts, we're talking about where the graph intercepts on there. Okay. The equation of this line, if you look at it, it has a y-intersect of 2. So we know that's going to be y equals something x plus 2. And if you look at the rise over the run, like it goes up 1 across 1, up 1 across 1. So we know it's just going to be 1x. So y equals x plus 2. Now, there's a couple of ways we can find the y and x-intercept. Sometimes you'll be given a table of values. If we create a table of values for this graph, let's just do that. And I mean, we can read it off the graph alternatively. When x equals negative 3, y will equal negative 1. Alternatively, I could put negative 3 in here. Negative 3 plus 2 is negative 1. When x equals negative 2, we can see y equals 0, I should say. Negative 2 plus 0 is 0. And when it equals 1, y will equal 1. When it equals 2, y will equal 2. Negative 1, that should be. When it equals 0, x will equal 2. 0, y will equal 2, I should say, not x. When x equals 1, y will equal 3. You can put 1 in here. 1 plus 2 is 3. When x equals 2, 2 plus 2 is 4. Or you can read off the graph. 2, 4. And when x equals 3, put 3 in here. Oh, it's going to be 5. Or I can read that off the graph as well. Go to 3. We can see it's at 5. So you've got coordinates here. Now your x-intercept, as we said, y will equal 0. So when's y equal 0? That's my x-intercept, negative 2. X-intercept, x is always going to be 0. Where's x equals 0? That's going to be my x-intercept. So how does this help? Well, we know that if we give you an equation like this and you need to graph it, there's a couple of ways you could do it. You could do your point where you know your y-intercept is going to be, and then you can try and do the gradient. We're going to look at today graphing it from the x and the y-intercept. So if I've given you a table, we could fill out a table of values to do that. And I can say, hey, look, I know that the x-intercept is going to be at negative 2, 0. Which is here. You can put a point there. And I know the y-intercept is going to be at 0, 2. 0, 2 is here. And then you can just draw a straight line between these two. That's one way to do it, is via the table of values. The second way to do it is probably a bit easier. Well, we know y equals 0 on the x-intercept. So I'm going to sub in when y equals 0, and then I'm going to solve for what the x value would be. 0 equals x plus 2. So I've said, hey, if y equals 0, what does x equal? Well, you're going to minus 2 from both sides. X will equal negative 2. So therefore, we know that the coordinate is negative 2, 0, because we substituted in 0 for y, and x has to be -2. The other thing, that tells us where our x-intercept is, -2, 0. And then you can put a point there. This one, we can also, to find our y-intercept, well, we know to find our y-intercept, the x-coordinate is always 0. So I'm going to sub in x equals 0 into the equation. Y equals 0 plus 2. Y equals 2. And that's why that's our x-coordinate. Because if you're always substituting 0, if you hear 0 times anything, we'll just be left with that one. So that's why that's always our y-intercept. This is always our y-intercept because 0 times anything, because we know that x-coordinate is 0 here, if it's written in this format, we'll just be left with this number. So therefore, we know that the intercept of this is going to be 0, 2. And you can put a dot there. And then you can draw a line between them. So I'm going to go through a couple of other questions and see what they'll look like. Please take some notes down for these ones as well. So we will look at this. For the equation y equals 3x plus 6, find the x and y intercepts and graph, and hence find the y-intercept, I should get rid of that, comma, hence graph the linear line. All right, so first of all, we have to find the x and y intercepts. Well, to do that, to find the x-intercept, we know that on the x-intercept, the y-coordinate's always 0. I'm going to write this to find x-intercept. We sub in, sub meaning substitute, y equals 0, as this is always, or guaranteed you could say, always the y-coordinate. On the x-axis. We always have a y-coordinate of 0, so we sub that in. So we've got y equals 3x plus 6. Sub in y equals 0. 0 equals 3x plus 6. Minus 6 from both sides. -6 equals 3x. Divide by 3 on both sides. -2 equals x. Therefore, the coordinate would be -2 for our x, because that's what we found when x equals 0. 0. Now I'm just going to continue my writing over here. And I wouldn't normally write this. I would just literally write this part mathematically. This is just an explanation for you guys. To find the y-intercept, we sub in. Think about the y-intercept. It's along here. Where does it intercept? Well, we always know that x equals 0. We sub that in as this is always the x-coordinate. On the y-axis. So we're going to sub in. So I'm writing my equation, y equals 3x. This would be the mathematical working that you'd normally show out, plus 6. And we're going to sub in, because we're trying to find the y-intercept, x equals 0. Oops, not 3, it's x equals 0. Y equals 3 lots of 0, which is just nothing, plus 6. Therefore, y will equal 6. So therefore, my coordinate of this will be 0, because for my x, I substitute that, 6. Now I've got 2 points. I'm going to write another thing. From these 2 points, we're going to plot them. So we plot them, and then draw a straight line between them. Now, why do we know it's a straight line? Because we know it's a straight line because it's a linear equation. So that's what we do, okay? So we have 2 coordinates. We've got -2, 0, and we've also got 0, 6. So now I can put those on. -2, 0 would be like maybe here, right? And then we've got 0, 6, which is way up here. Now I just get a straight line, get a ruler, put your ruler between these two, and then you're just going to rule a straight line between these. And then if you're doing more than one graph on here, you would always label this graph. If you're only doing the one, you don't need to. And it's good to keep the color the same too. So if you have like 3 or 4 graphs, you would label the graph next to it to show what it is. Technically, you'd do it next to it. If it's getting really close, you can actually write it on the line alternatively as well. So what I will be getting you guys to do today when you're doing these questions is use one axis to do 3 graphs, so you don't have to keep on doing them. But yeah, so all you're doing to find just to summarize what we're doing here, to find our x-intercept, we just let y equal 0. We substitute that into the equation, rearrange it, and it gives us our one coordinate. Find the y-intercept, we let x equal 0 because x is always going to be 0 on here. Substitute x equals 0 in, you get a y coordinate. That tells you the coordinate for 0, x, and what the y is. You have those 2 coordinates, you plot those on, you draw a straight line between them, and you have your answer there. The only other thing you may get is you may not actually get an equation. You might just have a table of values. Well, even if you've just got a table of values, I could still graph this from my x and y axis. I know that when y is 0, -2, that's going to be my x-intercept. I could put a point there. And then I can see, when x is 0, y equals 2. That's going to be my y-intercept, 0, 2. I can put those 2 and I can graph those as well. So you may get a table of values where you need to just graph them. You may not have a rule. Alternatively, you may have a rule. If you've got a rule to find your x-intercept, you just substitute in y equals 0 because we know the y coordinate along there is going to be 0. You rearrange it and you get -2. That's a point -2, 0. Pop that on. To find your y-intercept, we know that the x coordinate is always 0 for our y-intercept. Substituting x equals 0, y equals 2. You've got a point 0, 2. Pop those 2 points on and a straight line. And that is it. If you have any questions, please let me know. But really, that is the main concepts for how we graph a straight line from x and y. And why we can graph this from a straight line is because the equation is in the form of y equals mx plus c, where n can be a number and c can be a number. If it's written like this, and x is only the power of 1, it's going to make a straight line, and we have looked at that. So good luck. Yell out if you need a hand with anything, and I hope that it makes a bit of sense for you, and I'll help you if you need it. And y-intercepts is probably the easiest way to graph these ones, and that's why we're starting with that, because you just put your 2 points on. You can easily find them by letting x equals 0, y equals 0, rearrange the equation, draw a straight line, and voila, you've got a graph.